Okay, so this is a problem, another one from Twitter. It's a intriguing one, right? So, okay, the problem says 7 to the power of x plus 24 to the power of x is equal to y squared. And of course, it's given in the problem that x and y are integers. Now, see, this looks, well, simply put, impossible at first, right? Because, well, it should be, right? There's infinitely many solutions. If you just think about it, there should be infinitely many solutions if like this condition were not there. And to be fair, I think there are, but I don't know if I want to tackle them. Uh, or maybe we will. Wait. Yeah, maybe we will. We'll see. So, okay, let's first try to brute force this. I don't know. Okay, right. So, I mean, yeah, the actual solution that I got was by like plugging in, right? What you do in like, what's that? 7th grade, 8th grade, or something? I don't know. Yeah, so what you do is you have an equation in two variables, you plug in for one variable, find the value for the other, and that's your solution, right? I think that's like a way you solve equations in two variables, but these are just, they're just a single equation. So, yeah, that's how I got the solution, but yeah, I'm pretty sure yeah. So, how can we like get something? Yeah, I was about to say, how can we solve this using like brute force or some stuff like that? Like, okay, maybe we can isolate y. So y should be in the form of square root of 7 to the x plus 24 to the x, right? Exactly. Okay, we've isolated one variable. Let's progress. And of course, 2 minutes into the video, of course. Yeah, I'm really slow. Okay, so that's the form of one of the numbers, right? But both of them are integers. So, for this to be an integer, okay, so this should be an integer, right? So y should be, no, not y. This inside stuff should be a perfect square. 7 to the x plus 24 to the x should be a perfect square. Oh well, that's, wait, okay. We're just going in loops, aren't we? Okay. Oh, but for the sum of two numbers to be a perfect square, is there like a condition? I don't know. Let's see. I don't know, dude. I'm just gonna plug in, right? Because that's how I found the solution. So, well, let's say x is equal to 1. So our goal here is to check if y is an integer for a value of x, for a given value of x. Right, so we get y is well, square root of 7 plus 24, which is, I'm pretty sure, square root of 31 is y. So I just mentioned here, square root of 31, not an element of the set integers. Right? Yeah, good enough. Pretty good. Let's say x equals to, and of course we're going in terms of integers. Well, we're checking for the positive ones, but we'll see. We'll see. I guess. So x is equal to 2. Get y is, okay, what's 7 squared? That's 49. What's 24 squared? That's, wait, let me think about this. Yeah, I'm just gonna calculate it, why not? 24 4s are 96. Yeah, I know the table of 24 because I'm that much of a nerd. 24 2s are 48 plus 9 is 57. Okay, 576. 76, yep. So 576, what we get is square root of 625. And now squaring both sides. No, we don't. Oh, wait, no, I was about to square both sides. 625 is a perfect square. That's 25 squared. because 625 can be written as, if you didn't know, it's 5 to the 4th. 5 to the 4th can be written as 5 to the 2nd. 5 to the 2nd, and that's a square. 25 square. So yeah, that's one of the solutions, I guess. Right? Now what I was thinking was like this one I got like comparatively trivially, kind of, you know. But I don't know if these are like the only solutions. Can we do -2? Wait, okay, so let's like narrow down some stuff, right? Okay, so first of all, for 0, right? Okay, so there's 3 conditions, right? X can be less than 0, x can be equal to 0, or x can be greater than 0. For x equals 0, so for this one, if my marker would work, for x equals 0, we get, so anything to the power of 0 is 1, so 1 plus 1 is equal to y squared, which implies that y is equal to the square root of 2, and of course, we know that the square root of 2 is not an element of the set of integers, so therefore x cannot be equal to 0 ever, right? Okay. Well, for less than 0, let's see. For a value less than 0, let's x equals -1. Let's try that, right? Y should be the square root of, 1 upon 7 plus 1 upon 24. But these are not integers, so this is not, which is not an element of the set of integers. Pardon my handwriting. Yeah, I think let's try like x equals -2. Yeah, it's just gonna get smaller and smaller, so this is going to tend to 0, right? As x goes to negative infinity, I think. Yeah, pretty much, right? Because then this becomes 1 upon infinity, that's 0. Okay, yeah. So, you know, I guess we can write this as formally as limit as x tends to negative infinity of 7 to the x 4 to the x is equal to 0. Yeah, I guess we can write that. So, and of course, this is a value that's okay. So, for x equals 0, we get root 2, right? Let's think about this. Okay, so for x equals 0, we get y equals root 2. I don't know, I want to graph this so bad, but yeah, so for x equals 0, we get y equals 1, 2, so it's somewhere around here, right? And then for this one, let's think about this. Let's try x equals -2, maybe that's convenient or something, I don't know. Y is 1 upon 49 plus 1 upon 576, and these are just the property of exponents. It's easy enough to see that, I hope. Now, is that going to be okay? So what's the inside going to be? This is going to be really complicated, but I guess we'll try. Yeah, we have time. So 576, right? 576 plus 49 is yeah, okay, that's a perfect square. As we saw here, that's 625 upon 2 perfect squares. 49 times 576. Square root of this stuff is y, which should be, okay, so this should be 25 upon 7 times 24. Okay, and of course that is not an integer, right? And let's simplify it just for the sake of it. 7 times 24, that's, is that 168? Yeah, 168. 25 upon 168. Y is equal to 25 upon 168. And what that equal to? Let's see, approximately that should be. This is like really approximate. I'm like, so it should be like, okay, the 4, 5, 6, 7. 1 upon 7. Approximately, really. Because you cancel these out. It's really approximate. But yeah, it's really bad approximation. But it's a wiggly equal to sign. Which is, of course, less than root 2, right? Let's be about there. I mean, I really want to, I'm tempted to solve this one now, right? So y is equal to, okay, if my marker would work, square root of 1 upon 7. Okay, so 24 plus 7 upon 24 times 7. And of course, it is 31 upon 168, which is, I don't think 168 is a, yeah, no, I don't think, I don't know per se if it is or isn't. Let's see, right? So 35 or 150 plus 5, 155, right? 31 times 5, 155. Okay, so it's a little less than 5. 5 minus some arbitrary, not arbitrary, but some constant a. I can't, yeah. I'm not that great at math. But I am pretty sure that's, now this is of course, and of course a is in between 0 less than a less than 1. Right, we're going to, we have those many conditions. A is just somewhere in between that range. Okay. And of course, wait, 5 minus a should be 5 plus a? No, it should be 5 minus a, yeah, I'm right, okay. And of course, the square root of something subtracted inside. Maybe I should remember this. Maybe I should prove this in a later video though. Square root of, yeah, I'll remember this, I guess. Square root of a minus b is always less than square root of a. Maybe I can prove that some later time. But yeah. Yeah, imagine, right? How easy is that going to be to prove? I'm not going to even attempt it right now. Okay, so yeah, we have that stuff. And this is going to be, well, it's going to be less than 5. Less than square root of 5, sorry. Square root of 5. Y is less than square root of 5, but yeah, y is less than square root of 5. What's square root of 5 though? So it's somewhere around here, right? Okay, so it's going something like this or something. I don't know. No, it's exponential, right? So it's going something like that. It doesn't touch 0, it goes to negative infinity, as we've seen like here, right? Yeah, we saw that. So pretty much, is it possible for, let's think about this. Oh, I just got something. Okay, so this is not true. It should be 1 upon. Yes, so okay, so we get for y equals that, right? Yeah, it's an exponential curve, it goes down, it's an increasing exponential curve. Yeah, we can see that, right? Okay, so I'm just gonna change markers because I don't know why this marker hates me, but it does. Okay, there we go. Yeah, so basically, okay, so we have, yeah, so that's 0, right? For negative 1, we got 1 upon 5, but this number should be, yeah, this number should be less than 1 upon 5. So minus a. A is some constant that I don't know the value of, but you could easily find it, I guess, using a calculator or something. You know, not that tough. Okay, so yeah, so far it makes sense. And this is going to be less than square root of 1 upon 5, and it's less than square root of 1 upon square root of 5, right? Now, because, okay, so y in this case, in this very case of x equals, what did we take? Negative 1, right? Yeah, x equals negative 1. Okay. No, it's less than 1 upon square root of 5, right? But it's somewhere around it, I guess we could say. Y is approximately 1 upon square root of 5 for x is equal to negative 1. For x is equal to negative 2, we have 1 upon 7. And of course, so comparing 1 upon root 5 with 1 upon 7, I think. Okay, so since no, let's not write that. That's like really bad to write. Yeah, so we're gonna use this statement, right? Because we know that the square root of 5 is surely less than 7, right? We know that for sure. Therefore, we can say that 1 upon the square root of 5 is going to be more than 1 upon 7, which means that we have proved that this graph is going to degrade, right, as it goes down, right? So it's 1 upon root 5 should be what's square root of 1 upon, let's rationalize that, right? That should be 1 upon root 5 1 upon root 5, let's multiply top and bottom by root 5, so we get root 5 upon 5. Square root of 5 is, I think it's approximately like 2 point something. Say it's like 2 upon 5 and 0.4. It should be more than 0.4, of course, yeah. So it should be somewhere along here, and then 1 upon 7 is if only I could remember the decimal expansion. Okay, so 1 upon 7 is wait, yeah, I think this is like 1 upon, that's like 142.857. I remember it. I played with pi sometime, and I don't, right there, and then it's just like really low, and then yeah, basically you get the idea. It goes never touches 0 because it does that at infinity, negative infinity, pardon. Okay, we've proved that much. Of course, starts out at square root of 2, and because square root of 2 and then it immediately goes down below 1, it's always between, okay, so for x less than 0, y, okay, so the range for y should be, well, square root of 2 is always greater than y, and y is always greater than 0. And because we directly jump to negative 1 and we proved that negative 1 is not an integer. Yes, we can just say that there are no negative solutions, that's why. Closest integer, y equals 1. Can we solve for y equals 1? Well, okay, I guess we can try, but I'm pretty sure x won't be an integer. Only hope. Yeah, y equals 1, only hope. So, okay, yeah, 1 is the square root of something. 7 to the x plus 24 to the x. Of course, squaring both sides, we get 1 is 7 to the x plus 24 to the x. Why am I writing my x's weird today? I don't know, man. Okay, so for these to be okay, can we have this? I don't know, dude. I know how to simplify this one. Okay, wait, I'll have to think about this. So we get 7 to the x plus 24x, 24 to the x, sorry. Right, oh yeah, which is not possible because you know that x has to be an integer and, well, yeah. No. Nope. So x cannot be greater. Is that how you write cannot be less than 0? I don't know. So x has to be greater than 0. That's the only possibility. We have conclusively proved that, right? Now, I don't know. This is the solution that I'm getting, right? X equals negative 2 is not a solution. Wait. Is y equals negative 25? Oh, yes, yeah. We can say, okay. So I'm going to rub this conclusive proof. Hopefully you got the idea because it's like really messy and it's messing with my head mostly. Yeah. I'm not that neat with my work. Maybe that's why. Score less. I don't know. Okay, so like we've proved that x has to be, I'm just gonna write it here, x has to be greater than 0, right? X has to be greater than 0. So, well, it starts from 1, no integer, 2, we get an integer. Now y equals negative 25 should also work because y is squared here and square of any negative number is positive. Square of any number is positive in the reals, right? So y should also be negative 25. So far we have two solutions, 2 comma 25 and 2 comma negative 25. Yeah, so okay, yeah, well, we got that much. Let's try x equals 3. No, then what? Like, I can't try out infinitely many integers. That's just impossible, right? Let's try x equals 3. Why not? But that's going to be very large. Exactly my point. Okay, there's a 2-digit number being raised to the 3rd power. That's large, dude. That's large. You know what? Maybe I'll come up with a good proof. Right? If I do, then yeah, that's great, right? Yeah, but so far we've got this much and we already have 2 solutions. I mean, come on. The question asks to find x and y and we found x and y. In fact, we found 2 y's and 2 similar x's but 2 distinct y's, and that's important, right? Those are 2 solutions. So yeah, that's pretty much it, I guess. Man, I love this. Okay. Yeah, after a long time, dude. Nice.